we're going to focus on polygons overall. So a polygon is a simple closed figure formed by three or more line segments. So it has to be a closed figure, and it has to have three or more line segments. Why couldn't it have two line segments? Why does it have to have three? Can you take two line segments and make a closed figure with it? No. Alright, so that's why it has to be three. The segments intersect at their endpoints. So they're not going to intersect in the middle, they're only going to intersect at the end of them. So the next thing we're going to do is we're going to look at some polygons and not polygons, and we're going to talk about them, why they are polygons or why they are not. Okay, so first ones we're going to look at, these are all polygons. So just draw it the best you can, it doesn't have to be perfect. So all three of those are examples of polygons. So on your assignment today, you will have to tell whether it's a polygon or not a polygon, and then you will also have to classify it. So looking at this first one, I'm already telling you it's a polygon. Why is it a polygon? What are the two requirements it has to be for it to be a polygon?
Three or more line segments.
Okay, three or more line segments. I guess there's three things. Tristan? What was that? Okay, they don't intersect in the middle, they only intersect at the endpoints. And what was the first thing that was in our note? It's a closed figure. Okay, so now when I look at this, how many line segments do I have?
Which one? Like all three of them?
Just in this first one. Four. We're at the top, bottom, and the two sides. So if I was to ask you to classify that, what's a four-sided figure called?
A square.
Square has to have right angles. Huh? I heard Lou say it. What was it? Quadrilateral. Okay. So let's look at the second one. Is it a closed figure?
Yeah.
Does it have three or more line segments?
Yeah.
Do the segments intersect at their endpoint?
Yeah.
Okay, so now how many sides does it have? 6. What's a 6-sided figure called? What was it? Hexagon. Alright, let's look at the last one. Is it closed?
Yeah.
Does it have 3 or more line segments?
Yeah.
And does it only intersect at their endpoint?
Yeah.
So how many sides does this one have?
4.
Careful. It's kind of hard to tell, but there's 1 here, 2, 3, 4, 5, 6. There are 6. Alright, so that one's also a hexagon. Now let's look at some that are not polygons. So So when you look at that first shape, it's a closed figure. It has 3 or more line segments. So why is it not a polygon? Right? They intersect in the middle. Okay, so that doesn't work. So it's not a polygon. What about the second one? Why is it not a polygon? It's not a closed figure. What about the third one? There's only one line segment because we can't count the arc of the circle as a line segment. Right? So it has to be a line segment. So that one is not. Questions on classifying a polygon or not in a polygon? Alright, so let's go through the names of some of the popular polygons that you will have to name. So, a triangle. And I'm going to put the number of sides above it, so that way if you forget. A quadrilateral. Anyone know what a 5-sided figure is called? There's a building in D.C. The Pentagon. Who remembers 6? We said it. Hexagon. Anyone know what the 7-sided figure is called? 7-sided is septagon. What's an 8-sided figure? Octagon. Anyone know a 9-sided? Might have had this question asked to you on the Pi Day walk. There was one of the questions about it. 9-sided is nonagon. Anyone know a 10-sided figure? 10-sided is decagon.
Once you say them, I know them.
You've heard them, yeah. Alright, so those are the common ones. As you get into the higher ones, there are like 30-sided figures. They don't have a formal name. They would just be a 30gon. Okay, so they just attach the number and then the word gon afterwards. So you might see some of those on your assignment. Okay, the next part is going to ask you to find the sum of the interior angles. So last week we focused on the triangle and the quadrilateral. And we said there's 180 degrees in a triangle, there's 360 degrees in a quadrilateral. But we're not going to tell you how many degrees are in a hexagon, or a septagon, or a 50agon. But we're going to give you a formula that can help you figure it out. Okay? Because you're not going to go around memorizing that a 15agon has whatever degrees. But if you have the formula, you can say, oh, I can figure that out quick. Okay? So I'm going to give you the formula first, and I'm going to show you how it works with a triangle and a quadrilateral since you already know those measures. So the formula, you will take n minus 2 times 180. And n is the number of sides. So you take the number of sides minus 2 times 180. So let's look at a triangle. How many sides does a triangle have? 3. So instead of n, I'm going to say 3 minus 2 times 180. Well, order of operations tells me to do parentheses first. So 3 minus 2 is 1. So taking 1 times 180, 180 degrees, which is what we said last week. A triangle has 180 degrees. Alright, so let's try it with the quadrilateral. How many sides on a quadrilateral? 4. So I'm taking 4 minus 2 times 180. So 4 minus 2 gives me 2. 2 times 180. Why do you have a calculator out? Nobody else has a calculator. Just because you're standing there doesn't mean you get one. 360 degrees. So let's look at one you don't know how many degrees are in it. So let's try a 20agon. So what am I going to do to solve it? Okay, so in parentheses I'm going to do 20 minus 2 times 180. So what's 20 minus 2? 18. So let's take 18 times 180. So I'm going to do it on the side here. Well, 8 times 0 gives me 0. 8 times 8, 64, carry a 6. 8 times 1 plus 6, 14. Add a 0. 1 times 0, 0. 1 times 8, 1 times 1. So add those together, I get 0, 4, 12, 1. So I get 3,240 degrees. Any questions?